Assalamualaikum and welcome back to our lecture. Today I'm going to continue our stiffness metric for beam problem number 2. For this problem, we already discussed for the numbering in part 1. By doing the numbering, we get this, and by using member stiffness metric, we have to assemble stiffness metric for member 1 and stiffness metric for member 2. So let's do for K1. Take the EI out, then assemble those value inside that metric, which is all this value. But bear in mind, you have to do numbering for member number 1, which is NY, NZ, FY, FZ. That already explained early on, is similar to thrust. So let's do numbering. For K1 is 6, 3, 5, 2. So 6, 3, 5, 2. So let's calculate what those values inside this matrix. So it's enough for you to do half side, then the rest you just copy it. So 1.5, negative 1.5, 1.5. It's a tedious work. You have to be careful. 2, negative 1.5, 1, 1.5, negative 1.5, 2. And half of it, you can copy it easily. For this one, go here. So 1.5. So this value, go here. 1.5, negative 1.5, negative 1.5, 1.5. So this one is 1, this one negative 1.5. So you can copy it easily because it's symmetry. So let's do for member 2, K2, take the EI out, do the numbering for member 2. Start with vertical first, then followed by rotational. 5, 2, 4, 1. 5, 2, 4, 1. 5, 2, 4, 1. Calculate those values inside. Alright, you done half side. The next side, you just copy it easily. Is the tips how to make it fast. Alright, we assemble our member stiffness for K1 and K2. Now we need to assemble structure stiffness matrix, which is capital K. We know K is equal to KD. Since our beam have two members, which is member 1 and member 2, by combine both, we gonna have matrix size 6 times 6. So 1, 2, 3, 4, 5, 6. So here is 1, 2, 3, 4, 5, 6. So this one is matrix 6 times 6. So Q equal to KD, takes the EI out. So we have K1 and K2 combined for each cell. For example, this one, cell 1, 1. What is the value in 1, 1 from K1? And what is value 1, 1 for K2. So from K1 is no cell number 11, but in K2 we do have cell 11. Row 1, column 1, the value is 2. So do it the rest for this structure stiffness matrix. 1, 0, 1.5, 0 is enough. Just do it half, then you can copy it. Alright, you done half side. The next one, and I said you just copy it easily. That save your time. Then you have to identify this line split between known and unknown. From this question, we know our d known, dk is d4, d5, and d6. But for this structure, there will be settlement about 1.5 mm at d5. We need to draw that line. So this d1, d1, d2, d3, d4, d5, d6. And we know our known d known, d4 is 0, d6 is 0, and d5 is also known, but with displacement downward 1.5 mm. So you convert that into meter, negative 0.0015. That's mean you're gonna have line between known and unknown, which is here and here. That split between known and unknown, certainly here. You can use this way. You have 1, 2, and 3. 1, 2, and 3. So this is a dotted line. So you know where is K11, you know where is K12, you know where is K21, and also K22. And for value K, back to the question, we know this question at node 1, we have moment clockwise 4 kilonewton, and this one anti-clockwise 4 kilonewton at 2. So if that direction similar to our numbering for rotational, that will positive. However, if that's moment rotation against rotation of our numbering, that is negative. That means the value for rotational at 1 is 4, which is positive. So at numbering 2, for displacement, there's no moment applied. So that means that's 0. And back to rotational 3 here, we can see here direction, this one against that rotational direction, so that's negative 4. So that's one for Q known. So for Q unknown is Q4, Q5, and Q6. Now we can find displacement by solving our QK here. So here is negative. So we solve this, then we can get D1, D2, and D3. Please do this. And also please make sure you know how to expand those matrices. Once you expand the matrix, you will have 3 equations and 3 unknown. That means you are possible to solve this simultaneous equation. Alright, right now please be careful, since decay in our problem here is not all 0, we cannot simply cancel it out. You have to be extra careful to expand matrix for K1, 2, and dk. So we know this is our matrix K12. This is our K12 times by D known. So this one. So you need to expand that. So to do that, for this cell, 1.5 negative 1.5 times by 0 plus by 1.5 times negative 0.5, 0.015, then plus 0 times 0. That's why you can see what I wrote it here. 0 plus 1.5 times negative. Similarly, you expand what is the value in here. So I wrote down here. So this one from 0 times by 0, then plus by negative 1.5 times negative 0.015, then plus 1.5 times by 0. So this is this value. And then it's possible for you to find what is D1, what is D2, what is D3. What's your value over EI, value for D2 over EI, and D3 is your value in over EI. Don't forget to write your EI in your answer. Previously, we know what is our value D1, D2, D3, and we don't know our Q4, Q5, Q6. And in here, we cannot cancel out our decay because it's not all 0, which is we have settlement. So you have to expand that. As you can see here, I already stated there those value in those cells. So please do this and you can get the solution for this answer. Also, you can refer to the notes I provided in column with the answer given. So for this one, Q4 is negative 0.525, Q5 is 1.05, negative 0.525. Unit is kilonewton. So we solve for problem number 2.